This video looks at application and utility software. So, software can be split into two main categories: system software and application software. So system software, things like operating systems and utility software, and they center around the running of a system and its hardware. Application software is all about the user and providing them with tools so they can carry out a particular job. So it might be a media player or a word processor. So we'll look at different examples of utility and application software. So utility software. So operating systems usually include a range of programs that perform a collection of useful functions. It might be keep your system secure, it might be keep your storage disks organized, it might be maintain the system. Now all of these extra bits of software that do these sorts of jobs are called utilities. So encryption software, that's an example of a utility. Encryption is where data is scrambled before being sent across a network so that it's unreadable if it's intercepted. And encryption software facilitates that process. So to encrypt data, an encryption key is used which will convert plain text into ciphertext. An encryption key is an algorithm and it will systematically alter each piece of data in a file. For example, a key may convert each letter in a text file to the next letter in the alphabet, for example. So the word hello becomes if-mup. And for ciphertext to be converted back to plain text, the same key is required by the recipient to reverse the encryption. So encryption software is an example of a utility, and we've just had a look to see what encryption was there. Formatting software. So formatting prepares the storage device for data storage, and formatting utilities obviously will allow this to happen. So it creates sectors and tracks on which data can be stored. It also creates a special list known as the file allocation table, or FAT for short. Now the FAT is used to keep track of where data is located. So every time you write a new file to your hard disk, the table will be updated as to where that data is stored. So I don't know whether you've ever heard of police recovering data from a wiped hard drive and how that's possible. Well, when you format your hard drive, you're not actually deleting the data on the disk, you're just deleting the table, the file allocation table. So the computer can't actually locate where the data is, and the computer therefore thinks it's empty. So if you were to try and write more data to your hard drive, it would just overwrite the data that was already there. But in fact, the data actually does remain, provided that you don't overwrite it. Okay, defragmentation software. So as I already said, when you format a disk, sectors are created in order to store data. These sectors are tiny, they're just 512 bytes in size. So that means that a file cannot be stored as one on the hard disk. It's split up into lots of building blocks. And over time these building blocks get fragmented over the hard disk, so they're not actually stored contiguously, they're not stored together on the hard disk, they might be stored scattered across the hard disk. So it means reading a file can take longer as the hard drive needs to be searched in multiple places instead of just one area. So to improve the read speeds, defragmentation software will search for data that's on the disk that actually is linked together, which perhaps is related to each other, and reorganizes them so that they are physically next to each other, so they're easier to read or quicker to read. So here's an example. You've got file 1 in orange, file 2 in red, and so on and so forth. Before defragmentation, you can see that these blocks sort of split up. The building blocks of each program split up, whereas after defragmentation they are put together quite neatly. So that's an example of defragmentation. Data compression software. So this is another utility, and this is where software can reduce the size of files. So there are different reasons why you might want to reduce the size of a file. You might want to store a file using less storage space. You might want to send the file to someone, and therefore if it's a smaller file then it can be sent quicker. And similar to that, if you're streaming things from the internet, then if they are compressed then you'll be able to view the file at much quicker rates because there's less data to be sent. So there's two different ways that you can compress files using compression software. That's lossy compression. So this is where unrequired data is completely removed from the file and not put back. So MP3s are an example where sound quality might reduce a little bit, but not that much. So sound MP3s, often certain frequencies that humans can't hear are just removed from that file. So the data is completely removed. It reduces the quality ever so slightly, but not really that noticeable to the listener. And then you've got lossless compression. So this is where data is only temporarily removed. So lossy is where you remove data permanently, but hopefully not to impair the file too much. Whereas lossless is where you temporarily remove data, but then you add it back in later on. So it might be that you have an algorithm that looks at the file and looks at the data and sees patterns in the data, and it sees that, I don't know, let's say an image file, for example. Imagine there are 1,000 black pixels all next to each other. Because it sees that pattern, it goes, okay, I'm going to remove all that data, and I'm just going to write down with this file that when we rebuild the file, we need to make sure that there are 1,000 black pixels all in a row in that particular part of the picture. So it will remove data temporarily, it will store it as a smaller file, it can be compressed, but then when you want to use that file again, it will rewrite the data back to its original form. Backup software is another type of utility software. So this allows data to be backed up. So backup is where a copy of data is stored somewhere else. And it's vital that data is backed up so that if you have data loss, maybe through an attack, through a natural disaster, through an accident, the data can be recovered. So if you imagine a large online store, if they deleted their database and couldn't recover it, the company would fail overnight. So we need to make sure that we can back up our data. And there's two ways that you can do that. You can do a full backup or an incremental backup. Now with a full backup, this is where the backup software makes a copy of every single file that you want to back up as it is at that moment in time on the system. So doing that each day, for example, will take a long time, but recovering the data is quick because you just need to recover or reload the previous full backup, and all the data will be recovered easily. Incremental backup. So this is slightly different. So this is where the software backs up the data that's changed since the last backup. So instead of a full backup every day, it might start up with a full backup, and then it might be that every day it just does an incremental backup. So it's just looking for the changes that have happened since the last backup and just backing up those changes. So it's much quicker to run the backup because it only looks for the things that have changed in the short term. But obviously, and it leaves an audit trail, which is quite good as well. But obviously, if you wanted to restore that data, you would have to restore every incremental backup in the reverse order, as well as that last full backup. So it can take a long time to recover the data. Okay, an application. So we've had a look at system software, operating systems and utilities. Now an application software, unlike those that sort of enable computer devices to work efficiently and effectively, an application is all about the user. So application software is another classification of software and includes programs like browsers, word processors, music players, software which allow users to perform a task. So you can have proprietary or off-the-shelf applications. So these are those sorts of programs that are made for the masses. So they're often generic functions to generic users. So it might be Microsoft Office Suite or Adobe's Creative Suite. All of these are off-the-shelf applications. They're written by companies sold for profit, and they're usually quite cheap because millions are going to buy these types of software. Now Bespoke is the opposite. Instead of writing a program for the masses, it might be custom made. So it might be that a particular user or a particular organization needs to have some software that is written that no proprietary software can actually satisfy. No off-the-shelf application can satisfy. And that's the main advantage of bespoke software. So they are written for specific users' needs. But the problem with that is that there could be a huge cost to create the program. You know, the programmers can only sell their product once, and it's going to take a long time to write it. So it can be very expensive indeed. They often have many bugs as well because only a few users will ever get to actually test the program. And if the user's needs weren't clearly explained before the software was developed, the software might actually turn out to be not that useful at all. Now, open source applications, this is a type of software that's freely available to anyone. So anyone can see the source code as well. That's why it's open source. They can see the source codes, they can see the actual coding that's happened, and they can edit it if they want. Okay, there's no copyright protection on open source software. And Linux is a really good example of that. So this is an operating system, a type of operating system that's developed by enthusiasts across the world, and they produce different distributions. All distributions use the Linux kernel at its heart, so that's what obviously gets the computer devices communicating with the software, but they alter they can rewrite the software, the operating system, to produce these different distributions for different uses. So groups of people then adapt it, and if they feel it progresses the operating system, they'll keep those adaptations and make it freely available to the public. And there's just a few of the distributions of Linux that you could get for free and install on your computer. Now, closed source is the opposite. This is where the actual source code is hidden. It's often protected under copyright law, usually only available to those who pay the copyright holder to use it. So the users won't have access to the source code, they will not be able to develop the software further. Often it's the off-the-shelf and bespoke software that uses closed source. So when you purchase software from a shop, you're not actually paying for the CD or the DVD or the downloaded file. You're paying for a license to use the software. So if you think about it, when a school purchases software, like they will get a single DVD or a single downloaded file, but they'll pay more because they are in fact purchasing licenses to allow lots of users to use the software. Okay, justification of applications for specific use. So in your exam, you might be expected to suggest a suitable application for a given context. You must make sure that you justify your choice. So your justification must include or may include a discussion about the features it offers and whether it meets your needs, the cost of the software and whether or not it outweighs the benefits that the software will bring, whether or not the source code is available, enabling you to develop further if you wished, the platform that the software can run on and whether you have the hardware to run it or not. So these are things that you should think in your discussions. And of course, whether or not the application is hosted in the cloud or simply on a single device.